Question 4, Part A. A pendulum is 90 centimeters long and swings through an angle of 0.6 radians. The extreme positions of the pendulum are indicated by the points A and B in the diagram. Part 1. Find the length of the arc AB. Use the arc length formula L equals theta r, where L represents the arc length of the sector, theta represents the angle inside the sector, and r represents the radius of the sector. So in this case, theta is equal to 0.6 and the radius r is 90 centimeters. So L is equal to 0.6 times 90, which equals 54. Therefore, the length of arc AB is 54 centimeters. Part 2. Find the straight line distance between the extreme positions of the pendulum. There are two ways that we can find the straight line distance AB. We could use the cosine rule, noting that triangle AOB is isosceles, OA equals OB, so we have two known sides and the included angle, or we can treat this as an isosceles triangle that's been divided into two congruent right-angled triangles, where the angle inside the right angle triangle is half of 0.6, so it's going to be 0.3 radians here and 0.3 radians here. We have a right angle here, and AC equals CB. And this is the approach I'm going to take in this particular solution. So triangle AOB is isosceles with OA equals OB, which equals 90 centimeters. The apex angle is 0.6 radians. OC, so that's this vertical here, is the altitude or the height of triangle AOB with OC perpendicular to AB with AC equals CB. So AC equals CB. And when we divide any isosceles triangle this way, it does produce two congruent right angle triangles. We don't need to prove this fact, but we can accept that at this stage. Now the question is asking for the length AB, or the straight line length AB. Now AB is twice AC. So we can find the length of AC using regular right angle trigonometry. Now this angle here, as I've stated before, is 0.3 radians. So sine 0.3 is equal to opposite over hypotenuse. So sine 0.3 is equal to AC over 90. Rearranging this equation to isolate AC, we get AC is equal to 90 sine 0.3, and doubling that, we get AB is equal to 2 times 90 sine 0.3, which equals 180 sine 0.3, which equals 53.1936. Just ensure that your calculator is set to radian mode and not degrees, or you'll get an incorrect answer here. Therefore, the straight line distance AB is 53.19 centimeters, correct to 2 decimal places. Part 3. Find the area of the sector swept out by the pendulum. Since theta is in radians, we can use the area of a sector formula, and that's given by area equals half times theta times r squared, where theta is the angle in the sector, and that's 0.6, r is the radius, and that's 90. So area is equal to half times 0.6 times 90 squared, which equals 2,430. Therefore, the area swept out by the pendulum is 2,430 square centimeters.